Getting audio. There we go. How to double check. So good morning to all of you guys. And we did get a little late start because there was a technical issue with the projector on the software, and here we had to get it on manually. Good. So we're functional. That's always good. I also want to say to you guys what I did yesterday. If you guys remember, we were working on graphing what? Tangent and cotangent. Is that true? So if you go to that worksheet, I may have to refresh. Sometimes you have to refresh because you have your cache. Let me see if I can. Let's see if it. Let's go back. Yeah, okay, so I'm going to have to refresh. Let's see if I do this, if that helps. So what I did here for you guys yesterday, I think I have to go back to the main page. I'm going to go back to the main page, refresh there. You guys already know the internet's a bit slow out here. We're in the dungeon. We're in the basement. All right. And let's go back. What I did yesterday for you guys is I actually posted the solutions for what? For the evens and the odds, not just the evens. So you have all the solutions, okay? You guys with me on that? And what I'll try to do also here, graphing sine and cosine, I think the video had the odds, but I think I'm going to do the same. I'm going to give you guys all the solutions, okay? So I'm going to make that a priority, and so you guys have all the solutions. I just want to let you guys know that, and then today, what I want to work on here is graphing secant and cosecant, okay? And let's see what I have here. I'll eventually probably have to do the same because I think the videos, I went over the odds in the videos. And for example, today, graphing secant and cosecant, I think it's in this video lecture for the odd numbers. So I want you guys to know that. I did put the odds there, and you can see the video solutions for the odds. But what I'll do is I'll put the what? Oh, I like that. Multiplying fractions, dividing fractions, good. I will put, ladies and gentlemen, here the solutions for all the odd numbers, but I think this is a great detail of graphing secant, cosecant. So, but you know, today I want to graph secant and cosecant here and share that with you guys, and how that's really done. Okay, so all right, so I guess let's start by graphing secant. And let's talk about that, okay? So we want to start to graph. So I just wanted to be clear that you guys have the answers for all of these things so that when you work on them, you could double check. And I think students usually like that. You do have a video there. It does make you search a little bit, but maybe that's something people don't feel so comfortable with. So I'm going to actually put up the answers the same way I did yesterday for the odds as well. So we're going to investigate how to graph secant. Okay? So I want to note something here. What's the relationship here between secant and cosine? Do you guys know what I'm talking about? So just to start off, very, very simply. Reciprocal. That key word we're going to look at today. Reciprocals. Okay? So you're going to see today, if I said to you, the number 2, what's the reciprocal for the number 2? Good. So 2 and 1/2 are what? Reciprocals. Is that right? So this is a little bit of the S. You say, what's in the S? This is a little bit of the S. 2 and 1/2 are reciprocals. What about 3? 3 and what? 1/3 are, again, reciprocals, okay? And then what if I said to you, what about 2/3? 2/3 and what number? 3/2, good, are what? Reciprocals. So, you know, I'm showing you guys some reciprocals here. Because generally speaking, you take any fraction, a over b, and you just flip it over. B over A, or what? Are reciprocals. This is the definition. So we're doing some S here, in addition to our late start. Okay. So these are the reciprocals. Just want to see here. People got they got the memo. Today's the what, 24th? And is this in trig, I think? Yeah, it is. It's in trig. It's weird. How come it doesn't copy? I said copy, copy. Yeah, that was the video, so we're good to go. Okay. So you might say, well, how come in the beginning I didn't see a fraction, right? So some of these questions in the beginning here, we didn't see a fraction. So you might say, well, what's going on there? Well, the number 2 is a whole number, but we can write it as a fraction. We write it as 2 over 1, 3 over 1, all those nice things, right? So that's why you see when we flip it over, the 1, and that's what a reciprocal is. So we're looking at this relationship, okay? And it doesn't matter if the number is negative. You can say, what if the number is a negative 1/4? What's the reciprocal? Well, it'll be negative 4. If the number is negative 3, it'll be negative 1/3. So it even applies to signed numbers or negative numbers, this definition, okay? And you might say, well, why do we care about this? Because when you graph secant, ladies and gentlemen, the key to graphing secant is to sketch the curve of the reciprocal of secant. What's the reciprocal of secant? Cosine. Good, ladies and gentlemen. And you guys know how to graph cosine, is that right? You guys know how to graph cosine. So if you're going to graph secant, you always start by graphing what? Cosine. So, okay. So because, you say why? Well, because there's a relationship that the secant curve is a reciprocal of what? Cosine. I should say the secant function and the curve. These are both reciprocals. And so I'm going to give you guys a note, generally speaking here. So if you said, okay, we're going to look at the graph of secant. We're going to look at those ideas. Yes, we want to consider what? Cosine. You say, okay, Mr. Judge, I'm going to graph the cosine curve. Okay. What's the period for cosine? Now, this is different from yesterday. It is 2 pi over k. Is that true? So if I'm looking at cosine, that period is 2 pi. K here is 1. Is that right? So it's 2 pi over 1, which is just 2 pi. So I know the period here for cosine. 2 pi. What's the interval of one cycle for cosine? Do you guys know? The interval is going to be, you start at 0. Is that true? And then you end where? 2 pi. So you're going to have to go back again. This is not tangent. This is not cotangent. This is now what? Just secant. Because they're reciprocals. Okay, now you say, what's the amplitude here for this? Well, the amplitude is what? There's a 1 there. Is that true? So we also know that an amplitude is the absolute value of 1, which will be 1. There it what? There's the information, okay? So we go, okay, let's graph this. And when you look at the graph, you have all the appropriate information here. One, what is this? Negative 1, 0, 2 pi. In the middle here we have what? Pi, and then we have this pi over 2, 2 pi over 2, 3 pi over 2. So, okay, this is cosine. Where does cosine start? Do you guys remember? Cosine starts at 1, at where the maximum value is. It then goes down to the what? The x-intercept, and then it goes to the minimum value, and then it comes back to the x-intercept, and it's back at the maximum value. So when you do this here, let's sketch it. Here's the x-axis. Here's the y-axis. This is, again, your one cycle of what? This is one cycle, ladies and gentlemen, of cosine. Okay, you guys with me on this? So if I go to Desmos now, and I want to do that because I like showing you guys this information in Desmos. Graphing cosine and one cycle, we'll clean it up so you guys can see this. 0. Last one, go to x. Last one, you go to 2 pi. And I'm going to paint that blue this morning. I have to fix the y-axis, as you guys can see. So you guys can adjust that too if you're ever working with Desmos as well. Okay, and you see a graph that's not really, it's not just the y-axis. I think there should have been a key here that, even the x-axis looks kind of little. Say -1 to, I don't know, how about this 10? That looks a little better. Okay, let's do the x-axis again. I said -1. Let's do 8. That looks a lot better. What do you guys think? Isn't that the graph of cosine? Okay, now I'm going to do something here for you guys and share with you guys something here. Let's see what secant looks like. Y equals, ladies and gentlemen, secant now. And I'm going to use the same interval. Okay. And with this blue curve, let me change this. Let's put this in, it could be purple. Let's say here, this blue curve is dotted. So I'm going to dot the cosine curve, and I'll keep the what? The secant curve. So in purple, you guys see the secant curve. And in blue is the cosine curve. I'm going to point out some very special features, okay? Remember, where's the x-intercepts for cosine? We already answered all those questions. So the x-intercepts for cosine, I'm going to go back over here, okay? The x-intercepts for cosine is going to be pi over, I think it was pi over 2, is that right? So I'm going to put pi divided by 2. There's the x-intercept. You guys can see my point. Okay, pi over 2. And the other one is going to be 3 pi over 2. So we get 3 pi over 2. Okay, so let me bring this in to notability so we can go through the details. We're going to make some very interesting observations, okay? So, alrighty, there we go. We'll import that into notability. Okay, so let's make some observations so you guys can see this here. So you might say, hey, Mr. Judge, I know something about vertical asymptotes. They happen at pi over 2 and 3 pi over 2, and these are in purple. Notice these lines never cross those lines. The purple secant curve never crosses your vertical asymptotes. And then you might say, what's so special about the minimum value here and the maximum values for cosine? Okay, because remember what's going on here. If I said to you, in cosine, your maximum value is 1. Would you guys agree with that? What's the reciprocal of 1? No, 1. So that point is on the what? Secant curve. And so if I even went through the other values, like if this fraction is certainly less than 1, so you guys know, the reciprocal is greater than 1. So it'll be up here. And as you continue to look at points here, okay, you start to generate the points for what? Secant, because they're reciprocals. They're bigger than 1. So if the blue curve is smaller than 1, the reciprocals are bigger than 1. When you get down to 0 here, ladies and gentlemen, right, you get down to where on cosine you have an x-intercept. This is where you have those vertical asymptotes, because 1 over 0 is what? Undefined. And so you're going to see for secant, bless you, the curve get close and closer to that line. And that's why it's a vertical asymptote for secant. That happens at x equals pi over 2. That's why you see this line here that I put for you guys. At x is pi over 2, this is where your cosine value of the function is 0. So you have a vertical asymptote for secant. Remember, you can't divide by 0. Where is cosine 0? At x is pi over 2. So 1 over 0, that's what I'm saying, is undefined. So that's why you have that vertical asymptote. So That's why you see what you see here. Similarly, all the way to the what? This maximum value of 1 and these smaller values than 1, you'll have the same situation for secant. And as you approach 3 pi over 2, the same thing is happening. So you get all of these points here. So you get closer and closer to the x-axis, but you certainly never cross the x-axis. Okay, and that's why you see on the other side the same exact what thing. There's a vertical asymptote there. So you might say, well, what about the other portion in the middle? Well, go with the same logic. This point, the minimum value for cosine over here is -1. Is that true? So if you look at the reciprocal of that, it's also -1. So that's a point on secant. And all these other points that are actually larger than -1, they have reciprocals as well. And as you get closer and closer to the x-intercept in blue here, you get closer and closer to that what? Vertical asymptote as x is pi over 2. And I'll draw a little bit nicer picture. Same thing on the other side. All these points are larger. They get what? Move there. So in purple is the secant curve. And as you guys can see, you really want to draw what? The cosine curve, so you can draw what? The secant curve. And that's why you see what you see even in Desmos. So if I go back to Desmos and you said, well, what is really the secant curve? Well, it doesn't have, ladies and gentlemen, the cosine curve. What you see here is the secant curve. So this is the very famous graph of secant. So what you want to do is always graph cosine and then draw your vertical asymptotes. And that's easy to find. That's the x-intercepts. It's the x-intercepts for what? For the cosine curve. Right here and right there. You draw your vertical asymptotes. And at the amplitude maximum values, you can draw this curve going up. And the minimum value, draw that kind of parabola-ish curve going down. But that's essentially how you graph secant. The key is to always graph what? Cosine. Yes. Okay. You guys okay with that? So I'm going to look at my website over here because I get to use 2 computers. And like I said, when I go to the graphing the reciprocal functions in trig, they can give you something like the following, right? What if they said here, if I can get the right pencil, they want you to sketch the curve of secant of what? 4x. And in fact, we'll put a constant in front, 3 secant 4x. Okay, so you're going to go through now. Here's A, here's K. You're going to go through all the process again. The amplitude is the absolute value of 3, which is what? 3. What's your period now? 2 pi over K, is that right? Which will be, what is K here? 4, and what does that give you? It's pi over 2. So, ladies and gentlemen, you get the amplitude being what? 3, and you get your period being what? Pi over 2. Well, 2 divided by 4, remember, simplify your fraction. Remember, did we show that to you guys yesterday where you can find that on my website? 2 and 2 cancels, so you're left with what? Pi over 2. And we'll use the orange because that's what it is. So remember, I showed you guys that simplification video even. All right. Interval of 1 cycle is going to be what? You start where? You start at 0, and then you end where? Pi over 2. Okay, now you say, why am I doing this? Because what's the key again? Your key is to graph what? Cosine. So here's the key. Y equals 3 what? Cosine 4x. This is what you are looking at. So you said, oh, I got to graph this. This is why we're finding all that information. Yes, it is. This is what we call the reciprocal functions. So let's get to work on this. Your amplitude is 3, and this will be negative 3. You start at 0, you end where? Pi over 2. Do you guys remember that? What's halfway between 0 and pi over 2? Do you guys remember how to do that? 0 plus pi over 2 divided by 2 gives you pi over 4. Thank you. And then what's halfway between 0 and pi over 4? Right, 0 plus pi over 4 is pi over 4 divided by 2. What do you guys get? Pi over 8. Is that right? Now, this one, let's be careful here. This one, you might say, oh, Mr. Judge, that one is a tough one. Why is that one a tough one? Oh, yet again, halfway. Oh, what do you guys do? You guys remember some arithmetic? What do we do with that arithmetic? Pi over 4 plus pi over 2 divided by what? Divided by 2, is that right? Midway? Is that right? You guys okay with that one? So now, if I said to you, how do you add these here? What would you have to do? Multiply the top by 2 and the bottom by 2. And what do you end up with? This is what? Pi over 4 plus what? 2 pi over 4 divided by 2. And you end up with? 3 pi over 4 divided by 2. And now this is 3 pi over 4 divided by 2. 3 pi over 4 times 1/2 becomes 3 pi over 8. So that, ladies and gentlemen, goes, this is 3 pi over 8. Okay, you guys okay with that? So that'll go over here. Now I'm going to share with you guys something here. This is the mathematics. This is the arithmetic. But I want to share with you guys a little trick here that I use as well. I'm going to share with you. See this distance is what? Pi over 8. Is that true? I want you guys to double check. This is pi over 8. So you can think of this as 1 pi over 8. This is exactly the same distance. That's going to be now what? 2 pi over 8. Okay, see that same distance? What is 2 pi over 8 reduced to? Pi over 4, outstanding. And you want to know something? This will be what? 3 pi over 8. You go, but I just found that by doing arithmetic. And I'll say you can also find it by counting. And finally, the last distance is what? 4 pi over 8. So you say, what is 4 pi over 8? Well, simplify the fraction. Isn't that pi over 2? So if you had to review simplifying fractions, I shared with you guys a video yesterday, but this is a nice, quick, and easy way to either verify your arithmetic or even to get this middle value that we just did right now. Just count. And that's what I do. I just count. Personally, I don't even go through the arithmetic. But you say, why do you show us that? Because this is what you guys got to review and know how to do. And, you know, that's the way it is. But I can also show you how to count. I can show you both. Okay. Zero to pi over 2. So, ladies and gentlemen, we're graphing again what? Cosine, aren't we? We're graphing 3 cosine. So you start at the maximum value. You head down to the what? Intercept. And then you get to the minimum value. Back to the intercept. And then back to the maximum value. There you guys go. Is that the graph of cosine, ladies and gentlemen? Now let's graph secant. You ready to graph secant? So this is what you guys already know how to do by your homework. You say, oh, Mr. Judge, we worked on that. We already know how to do that. I'm up to date. I don't wait till the night before to do my homework. I'm up to date because I want to do well in class. I've learned how to succeed, and that recipe never gets you anywhere. And I've learned, if I've learned anything being here, I've learned what you said, and I'm up to date. I'm good to go. So I say, okay, how do you then graph that 3 secant 4x curve? Start with your what? Vertical what? Asymptotes. Where do they happen? At the x-intercepts. So I've always asked you, hey, when you graph cosine, where's the x-intercepts? And you say pi over 8, 3 pi over 8. Why do you think I ask you that? So that you can know where they're at, so you can use all the information I'm sharing with you. These are the vertical what? Asymptotes. And you know what they are, because tangent and cotangent has the same. So how are you going to start to how to sketch the secant curve? Do you guys remember? What does that picture look like? The horns going up, and then the parabola in the middle. So you're going to draw the horns. Draw the what? Draw the horns, if you want to think of it that way. So your horns look like this. Are those the horns? Now draw the what? The upside down parabola. Make sure you don't cross the the vertical asymptotes. So here you go, ladies and gentlemen. You're down here. You're going down here. Easy peasy. Lemon what? Squeezy. So that's the key. You just have to graph your what? Your cosine curve, and then you get the secant curve free. Freebie. That's it. Draw the vertical asymptotes and then do what? Sketch the curve. So you definitely want to know that pattern there, for secant. And, generally speaking, for secant, you don't have that information there, right? You just have this. Easy peasy, lemon what? Lemon squeezy. Okay, what if they give you y equals 1/2 secant negative pi x? And they want you to do the same. I would say remember this about secant first, right? What do you guys know about that number? It's negative. Secant is also what? Is that an even? I think secant is even. Is that true? You say, how do I know that? Because cosine's even. So you go, oh, y equals 1/2 what? Cosine pi x then. Remember the key. Your key is to graph the cosine curve. So you can say, I'm going to go back over here. If you wanted to see those details here, let me erase it. Let me give you every detail. And there it is. Here's your key. So here's the deal. What's the period? Right? Do you guys remember? 2 pi over k. What is k? Isn't k pi? And doesn't the pi's cancel? So your period will be what? 2. All right. I think I forgot the amplitude. What's the amplitude? It's a here. Your amplitude, the absolute value of 1/2, which will be what? 1/2. Interval of 1 cycle. Start at 0 and where? 2. Okay, you guys have all the information to start graphing cosine. What's halfway between 0 and 2? Good. 1. What's halfway between 0 and 1? 1/2. Now you might say, I don't know about the next one. Well, go with this. Go with what I just showed you. 1/2, 2/2. What will this be? 3/2, and this is 4/2. Isn't it true 2/2 is 1 and 4/2 is 2? So we're graphing cosine. So you're going to start at the maximum value, get to the x-intercepts, go down to the minimum value, and then get to your x-intercepts, and then go up to the what? The maximum value. Sketch cosine. And then that's the key, right? But you're really sketching what? Secant. So the key was to graph cosine. Now we got to do the secant curve. Because remember, this here really is, secant is even. This is 1/2 secant pi x because it's even. So here now, ladies and gentlemen, at the x-intercepts, you just draw your what? Vertical asymptotes. X equals what? 1/2, and x equals 3/2. Yeah.
So do we still have to put like the max, minimum?
No, actually, no. You don't have to answer those questions. You just have to sketch the curve. And I think really all you really have to do that I'll ask is what are these lines called? Those are what? Vertical asymptotes. Good. And then sketch the what? Sketch the secant curve. And so you start again with the horns, right? There it is. And then you go to the upside down parabola here. And, sometimes students will leave the cosine curve there and say, here you go, Mr. Judge, and that's fine. And sometimes students will erase them. So it doesn't really matter. And that's pretty much it. You would probably just ask for the vertical asymptotes and sketch the curve. It'll probably be a question where you first have to graph cosine and then ask the student to graph the secant version as well. Okay, you guys okay with that? So remember, what was I really attempting to do here? What if you got a negative value, right? So if they gave you, for example, hey, what is y equals to a negative value there? Like maybe a negative 2/3 secant what? What did we do? I think we did, okay. How about x over 5? They want you to sketch that curve, right? And you go, I know what the key is. sketch y equals negative 2/3 cosine x over 5. That is my key. So then you go through your process. You say, okay, want to find the amplitude. This is my A value. This is going to be, we'll find out what K is. So we take the absolute value of negative 2/3, which will be what? Positive 2/3, okay. Now, remember what happens over here. X over 5, isn't that going to be what? 1/5 x. Okay. So what's the period going to be? 2 pi over k. What's k? Which will be 2 pi divided by 1/5. 2 pi times 5, which is now 10 pi. So here's my period. Interval of 1 cycle. You start at 0, you end at what? 10 pi. Okay, so let's go through the process. We already know how to graph cosine, but be careful. This is that negative cosine. You think that's going to be an issue? Yeah, we'll show you how that works. Graph the negative of cosine. So if your amplitude is 2/3, okay, remember the period, the interval of 1 cycle is 0 to 10 pi. So how do we start that? Do you guys remember? What's halfway between 0 and 10 pi? That's going to be 5 pi? Yeah. Exactly. What's halfway between 0 and 5 pi? 5 pi divided by 2? What's halfway between 5 pi and 10 pi? Isn't that 15 pi over 2 if I add them and divide by 2? Is that true? You guys okay with that? So this is the negative of what? Negative of cosine. So the negative of cosine, where does it start? It doesn't start at the highest value. It starts where? The lowest value. Good. You guys remember that. It starts here, goes to your x-intercept, and then it goes to the what? Largest value, back to the x-intercept, and then back down to the what? Lowest value. Okay, so you're sketching minus cosine now. Okay, you guys okay with that? Here's the minus cosine curve. That's what we're looking at here. But we have to graph the minus secant. So again, start where? Where do you guys start? At the vertical what? Asymptotes. Happens when x is what? Okay, and then the other vertical asymptote. So here's the point. Sketch your horns. Their horns are going down now. Okay, the horns are going down. And then the parabola portion is actually opening up, not down. So it's the same process, but it's reflected about the x-axis. You guys okay with that? So you're reflecting this about the x-axis. And there's the curve. Now, do you have really the negative cosine curve pictured here? No, but this is the graph of that negative secant curve. Easy peasy lemon what? Squeezy. Now, I want you guys to know the same process happens if you graph now what? What do you say? What if I have to graph cosecant? What's the cosecant curve look like? Well, that one has the key because what's the reciprocal of cosecant? Sine. So the key is to graph sine. So it's the exact same process. You just have to graph sine now. So if I share with you guys in Desmos, and I'm going to get rid of these things for now. You might say, where does that graph of cosecant come from? You say, Mr. Judge, where in the world does this come from? How is that the graph of cosecant? Well, didn't we say graph sine? Okay, and then you say, what about those vertical asymptotes? Well, that's going to be, you got actually 3 of them. Right, so you're going to have at 0. Over here, this will be, no, this will be at pi and 2 pi. And I wish I can add, oh, I can add it. Can I add? We'll see. And if you like, Well, maybe an orange curve. You guys okay with that one? You go, whoa. So it behaves very similarly. Plot the x-intercepts. You're going to use that for the vertical asymptotes. And then you got two parabolas now. One opens up, one opens down. So I'm going to share with you guys how to do that again. So if they give you, as an example, they say, okay, they want me to sketch the curve of, I'm going to look at my notes. Y equals 4 cosecant of 1/6x. Okay, what is the key? You guys remember the key is? Yes, graph the reciprocal function for sine 1/6x. Use all the information you know. A, K, your period is 2 pi over K. What's K? 1/6, which is 2 pi divided by 1/6, which will be 2 pi times 6/1. So isn't your period 12 pi? 12 pi. Okay, now, interval of one cycle, start where? At 0 and at the period, 12 pi. Okay. And then, ladies and gentlemen, what else do you guys have there? What's your amplitude? Amplitude is the absolute value of A, which will be 4 here. So let's put these ideas together now. You're going to graph the sine curve so you can graph secant, right? So I'm going to try to, maybe I'll just put it right here. Maybe it'll fit. Zero to what? 12 pi. Okay, what's halfway? Good, 6 pi. What's halfway between 0 and 6 pi? Okay. What's halfway between 6 pi and 12 pi? Isn't that'll be 18 pi divided by 2, which is what? Your amplitude is 4, is that right? And then, okay. But you're going to have to graph what curve again? What curve is this? This is what? You graph sine, is that right? So how do we do that? Let's graph sine. Sine starts where? 0. And then goes to the largest value. It goes back down to what? And then it gets to the minimum value. Then it goes up here. And so we're going to sketch this curve. Okay? We sketch the sine curve. Wasn't that the key, ladies and gentlemen? To sketch sine? All right, remember this, ladies and gentlemen. Why do you want the sine curve? You want to draw the vertical asymptotes. They always happen at the x-intercepts for sine. So you have the first vertical asymptote, the second vertical asymptote, and then you have the third because, you know, you go to those x-intercepts. This is why I ask you for them when you graph sines and cosines, so that you can find these vertical asymptotes. It's extremely important. Okay, you find that, you find this, you find that. Now, what do you get to do now? Sketch the two parabolas. Now start here, and you can sketch your first up parabola, and then the down parabola going down. Easy peasy lemon what? Lemon squeezy. So we had a day, I think, where what? You guys know? We had a day where what's going on? Is it Halloween yet? I don't think it's Halloween, is it? Is it next week? Well, ladies and gentlemen, we had a day where we almost didn't have a projector, but thankfully we found a way. All right? And so I'm going to say to you guys, go here to that website, assignment, if I can access this. I'm going to add to the list graphing secant and what? Cosecant, okay? Okay, so that is on the website. I'm looking at it now. And ladies and gentlemen, yes, you have the solutions for the what? The evens so far. And this is the kind of stuff that you want to look at. Period, interval of one cycle, vertical asymptotes. There are no x-intercepts here, so ladies and gentlemen. But these are the solutions for the evens. And I'll work on getting you the odds as well. So maybe you can start on the evens first. But now you have another tool to graph, okay, ladies and gentlemen? So see you guys tomorrow. Take care and stay safe.